Welcome to fifth in the series of videos on electromagnetic induction. In this video, we're going to talk about transformers, one of the applications of Faraday's law. So first, let's take a macro view, and instead of getting into the details of how transformers work, but let's take a macro view. You find two kinds of transformers in general. One is called step-up transformers, and the other is called step-down transformers. So this is something you find near your house. This is found near your house, and this is something you find near generating station. Now, what happens is you have this, a generator producing about 11 kV kilovolts of voltage. Let's say this generator is, so this side which is giving an input to the transformer, we call it the primary side. So the primary side is analogous to your input, and your output side of the transformer is where you get an output, is we call it as a secondary. So this is an output. Okay. The input, the primary voltage of 11 kV. So your objective is to increase this voltage. So the step-up transformers, what it does is the step-up transformers steps up the voltage by a factor, and let's call that factor N. Okay, this is a factor of increase in voltage. So this is a factor of increase in voltage, right? Increase or decrease. So factor of increase or decrease in the voltage. So in this particular case, a step-up transformer, what it does is, let's say for this step-up transformer, your N is 50, okay? Or let's take a smaller number, let's say 12. So you're stepping up by a factor of 12. So what you get in the output is 12 into 11 kV. That is equal to 132 kV. Now, in a moment, I will tell you why you need to do this. But let's now move to the current. So if your current produced by the generator is about 1200 amperes, that's a lot of current, but that's what generators produce. Then what you will find is a current. If the voltage is increased by a factor of 12, your current will reduce by the factor of 12. That is equal to 100 amps. And the reason why this happens is because we want to make sure that the power of the input is equal to the power of the output, right? Or in other words, you want the EP into IP to be equal to ES into IS. So if your ES increases 12 times, then your secondary current, it will be reduced by 12 times, so that both of them can get cancelled, and both sides can be same. So that's the reason why you have the primary current going down by a factor of 12 when your voltage goes up by a factor of 12. Now, why do you want to increase the voltage and reduce the current? And this can be understood by thinking of a transmission line. So if this is your transmission line, you know that your transmission line has a resistance, right? Now let's take a case if you are transmitting current of 1200 amperes. The loss that you have is I squared R. So that is equal to 1200 squared into R, and that is equal to 144 into 100 squared into R. Now if you pass current at 100 amperes, which is what this transformer does, this transformer does, it translates 1200 amperes to 100 amperes, then your P loss is going to be I squared R again, but this time I is 100, so it's 100 squared R. So if you find the ratio between both these losses, you will find that this guy has 144 times the loss of this. So 144 times the loss of 100 amperes. So if you reduce the current by 12 times, then you improve your efficiency by one, or power loss decreases by 144 times. So that's the whole idea. That's why you want to reduce your current. Now, a step down transformer does exactly the opposite. It takes an input of a very high voltage, and it gives an output in the secondary. And a step down is, let's say n is 1 by 50. Here step down means n is less than 1. So here your n was 12. So it increases voltage. Here it decreases the voltage by 11 kV by 50 times, and that gives you 220 volts, right? And of course, if your current here is going to be, let's say 2 amperes, well, your secondary current is going to, since your voltage is brought down by 50 times, your secondary current will have to go up by 50 times. So the product remains the same, right? So your 100 amperes. So current will go up by 50 times because the voltage went down by 50 times. So that the product of these two would give you is same as the product of these two, right? So the power input and the power output is maintained. So that's the whole idea of a big picture of why we need transformers. Now let's see how we achieve this in the next video. So in the next video we'll talk about how transformers achieve this thing of stepping up, wherein you step up your secondary by n times the primary, and n is greater than 1, which means let's say example is 12, okay, in this case, and step down where you need your secondary to be n times EP, but your n is less than 1. So let's say example 1 by 50. So we will see how to achieve both of this in the next video. See you then. Ciao.